Hi folks, we're going to take a look at an example of sketching a sinusoidal function. Okay, so first thing I'm going to do before I think of anything else is I notice that the input here is not in factored form, so that's going to be my first step. Okay, right off the bat. So here, factor out the coefficient of x, which is pi over 5. So here we're left with, well, pi divided by pi over 5. The pi's cancel out. 1 over 5 is just equal to 5. Okay, so you see how I have that little conversation with myself to make sure I don't make a mistake. And of course, what you should always do is just do a quick calculation. So multiply pi over 5 times 5. 5's cancel out. Yeah, you get pi. Okay, not a bad idea to do that check. Okay, so now that I have that taken care of, I can start thinking about how I'm going to transform this function. So given that this is a sinusoidal function, I am not going to transform individual points, but I'm going to use the 4 parameters in this function to help me determine the major characteristics, to help me draw that. Okay, so let's start with the vertical stuff. Okay, so here we've got the amplitude. Okay, now remember that the amplitude is the absolute value of that a value in front. Okay, because the amplitude is a measure of distance, so it's always positive. So here we've got 7 and not -7. Okay, next we've got the axis, which can be found with this, what we call the c value there. So our axis is just given by y equals -2. And then now with these 2 pieces of information, I can determine the max and the min. Okay, so the max is just equal to that middle value plus the amplitude. So -2 plus 7 is equal to 5. And our min is that middle value minus the amplitude to get to the lowest point. So -2 minus 5, minus 7, which is equal to -9. Okay, so now let's work with the horizontal details. Okay, so we have this k value, the horizontal stretch. Well, that we know that that helps us determine the period. Okay, and the period is given by 2 pi, the original period, divided by the k value, pi over 5. Okay, so here pi is reduced, and 2 divided by 1 over 5 is just equal to 2 times 5, so the period is equal to 10. Okay, and the last thing is we have our phase shift. So of course everything that's horizontal is always the opposite of what we see. So here we have a phase shift which is 5 units to the left. So our phase shift is -5. Okay, and now with all these details I can draw the graph. So as with some of our previous more complex functions, okay, how we structure the graph is going to make a big difference into how well we can draw it and how precisely we can draw it. Okay, so let's look at the y values here. Well, I have to go from a minimum of -9 to a maximum of 5. So clearly I'm going to have to go up by, I think 2 units per box will do it. I definitely can't go up by 1. Okay, now for the x-axis, the important thing is not what the period is, but the fact that I want to divide this period into 4 equal parts. So whether this period was 10, 17 pi, 112, I just take that number and each box, okay, since I want to draw 2 cycles, if I want to draw 1 cycle, I could skip a box, but I need 4 equal parts. Okay, so I'm going to need 8 boxes for 2 cycles, since 4 for each cycle. Okay, but notice here that I'm going to have this phase shift 5 units to the left, which is half the period. So I'm going to leave 2 boxes on the negative side to help me deal with that phase shift. And the reason why I think of it in that way is the trick I use for graphing these is I first think about what this function will look like without the phase shift, okay, figure out where my points should be, and then just apply that phase shift to each of those important points. Okay, so here, since there's this goes further down on the negative side, I'll bring the x-axis a little higher. Okay, want to make good use of the space on my graph. Okay. So here our y-axis, we've got 2, 4, 6, and then here we've got 2, 4, 6, 8, 10. Okay. And now and of course these are negative. There we go. All right, and now for my x-axis, again, all I care about is 1, 2, 3, 4. There you go. That's going to be my period. Okay, so this will be 5, 2.5, 7.5, 1, 2, 3, 4. There we go. That'll be a second period length. Okay, and then here we got -5 on the other side. Okay, so before I again start plotting, I'm going to add more structure to this graph. So I definitely want to add in my axis, okay, because that'll help me to draw those middle points really easily and quickly. Okay, and I'm also going to add lines for my maximum and minimum. Okay, and we'll see as I'm drawing it just why that is so useful. Okay, so at 5 and at -9. Okay, all right, so now I have everything ready to go to sketch my graph. Okay, but again, I said I'm going to start with the all the details except the phase shift. Okay, so let's take a look at what our parent function is. Okay, our parent function, not a bad idea maybe to write it down. Okay, and I'm not going to think of this as sine x. I'm actually going to think of this as negative sine x. Okay, because that negative really hasn't come into play in terms of my other characteristics. Okay, so I'm going to think of my parent as negative sine x. And the reason why it's important to think about that negative, because sine normally starts at the middle and goes up. Since we're working with negative sine, we're going to be starting at the middle and going down. Okay, and here we're going to see why it was so nice to have all these lines drawn. Okay, because I'm going to start at the middle value. Okay, I'll make these small points for now, and then every quarter, the way I've set it up, I'm going to draw my special point. So here, negative sine goes from the middle to the minimum, back to the middle, to the maximum. Okay, and we see just how easy and quick this is. Okay. Oops, there we go. Okay, so this is what the function would look like without the phase shift. So all I have to do now is move all my points 5 units to the left to incorporate the phase shift. And these points here, I'm going to make them a little bigger so that they're obvious, okay, for me to see. So again, just move everything 5 units to the left. Okay, we actually see some points sort of go over other points. So here, 5 units to the left. Okay, 5 units to the left. 5 units to the left. Okay, and just keep going. Okay. And that's enough for now. Okay, and now we can draw the graph. So, again, you want to try to get that nice curvy feature to the graph. So no straight lines. I'm using a marker, so I'm going to go a little slower than I might go if I had a pencil where I could make some corrections. Okay. And there's my 2 cycles. But again, what I really want to do is I want to indicate that this function, keeps going on and on. Okay, and there you have it. So let's just do a recap. So step number 1, make sure you factor the input if necessary. Okay, from there, interpret from your 4 parameters all the important characteristics. In this case here, I'm talking about the maximum, the minimum, the period, and the phase shift. Okay. Indicate what your starting function is going to be. In this case here, it was negative sine. And then before you start drawing, make sure you set up the structure very carefully. So in particular, your x-axis is going to be guided by having enough space to draw your 2 cycles. So here I needed 8 boxes because I'm going to take my period and just divide it into 4 equal parts. And then for the y-axis, I just, figured out what was an efficient use of my Cartesian